4,000 meters above sea level. Oxygen at 60%. No trees grow here. Fire barely catches. A human body loses 15% of its work capacity in the first 48 hours. And someone chose this place, this barren, airless plateau in Bolivia, to build the most precisely engineered stone structure on the planet. The blocks are diorite, hardness 7 on the Mohs scale, harder than steel. A copper chisel pressed against diorite doesn't cut, it crumbles. And the glossy version of history says, copper tools and willpower. That's the explanation. For CNC-level precision, at 4,000 meters, in stone that eats metal. Who worked this stone, and with what? 1 second. Before we get into what's carved into this stone, we need to understand what this stone actually is, because that changes everything. The Bolivian altiplano, 16 degrees south of the equator. A flat, treeless expanse of brown earth and frost between two arms of the Andes. The air here is so thin that every step is a struggle, and your heart pounds like it's trying to escape. Altitude sickness hits within hours. Modern construction crews at this elevation rotate shifts every 4 hours and carry supplemental oxygen. The nearest forest is 1,000 meters below and hundreds of kilometers away. There is no timber for scaffolding, there is no fuel that burns efficiently, and there is almost nothing to eat. Agriculture at 4,000 meters produces quinoa, potatoes, and not much else. Building anything here is a logistical nightmare. Building the most precise stone structure on Earth here is something else entirely. And yet, the blocks are here, scattered across the plateau at a site called Puma Punku, roughly half a mile southwest of the main Tiwanaku complex. The nearest confirmed quarry for the diorite blocks is at Copacabana Peninsula on the shore of Lake Titicaca, roughly 90 kilometers away. 90 kilometers. Across terrain with no roads, no rivers deep enough for barges, no draft animals larger than a llama. A llama carries about 30 kilograms. The smallest H blocks at Puma Punku weigh several tons. The largest red sandstone slab on the site, a platform stone, weighs over 130 tons. Just moving the raw material to the construction site is a problem that the accepted timeline cannot solve without invoking an army and a miracle. And that's before a single cut is made. The main construction material is andesite and diorite. Andesite is volcanic, dense, gray. Diorite is worse. On the Mohs hardness scale, diorite sits at 7. For reference, a steel knife blade is about 6.5. Copper? 3. A copper tool pressed against diorite is like pressing a candle into a brick wall. The candle doesn't carve, it deforms. This has been independently verified by materials scientists. Christopher Dunn, a manufacturing engineer with decades of experience in aerospace machining, examined the stone at Puma Punku and concluded that the precision of the cuts is inconsistent with any known hand tool technology from the ancient world. Not because of skill, because of physics. Copper cannot remove material from a surface harder than itself. This isn't opinion. This is the Mohs scale. It's a physical law. Here's what no one says out loud. The official toolkit cannot touch this stone. The accepted answer? Bronze tools with sand abrasive. Let's look at the numbers. Experimental archaeology has tested this. Using bronze tools with quartz sand on andesite, a slightly softer cousin of diorite, Researchers at the University of Exeter managed to remove material at a rate of roughly 1 cubic centimeter per hour. 1 cubic centimeter per hour. Some of the channels carved into Puma Punku's blocks are over a meter long, several centimeters deep, and cut with tolerances under 1 millimeter. The math leaves no room for doubt. Even under the most generous assumptions, carving a single H-block with bronze and sand would take years of continuous grinding. And there are dozens of these blocks, identical, as if stamped from a die. Like trying to cut a steel beam with a butter knife and getting a cleaner edge than a laser. But copper can't do it. So what did? The blocks themselves hold the answer, if you look closely enough. The H-blocks. These aren't rough-hewn boulders. They're standardized components. Each one has identical grooves, identical channels, identical right-angle recesses, precision cut to receive interlocking pieces. The grooves match block to block. The depth is uniform across every specimen measured. The angles are 90 degrees, not approximately, not close enough. 90. Jean-Pierre Pratzen of Stanford University spent years at Puma Punku with calipers, straight edges, and laser levels. His documentation confirmed what any machinist would see at a glance. The internal surfaces of these grooves are flat to within fractions of a millimeter. The corners are sharp, the walls are parallel. This isn't decoration. This is engineering. A machinist would nod. An archaeologist would need a chair. And it's serial production, not one-off artisanship, not a master carver working decades on a single piece. This is a standardized modular system, like a factory floor producing identical components for assembly. The blocks were designed to fit together. They were manufactured to specifications, and the specifications were held constant across dozens of units. When you place two H-blocks side by side, the grooves align, the channels interlock, the fit is snug. The system works across blocks that weigh several tons each. We call this interchangeable manufacturing. We invented it, officially, in the 18th century. Eli Whitney, Musket Parts, the American System of Production. Puma Punku had it in stone, with tolerances tighter than Whitney ever achieved in metal, at an altitude where a modern factory would need pressurized oxygen just to keep the workers conscious. All of that from a civilization with no written language. But identical blocks only prove someone had a system. The drill holes prove they had machines. Several blocks at Puma Punku show perfectly circular bore holes drilled straight through dense andesite with visible internal thread marks, spiral grooves running along the interior wall of each hole at a uniform pitch. Based on the analysis of these marks, researchers have calculated a feed rate of approximately 1.5 millimeters per revolution. Hold that number. Modern CNC, drilling into granite, using tungsten carbide or diamond-tipped bits with hydraulic downforce and computer-controlled feed, operates at feed rates between 1 and 3 millimeters per revolution. The ancient boreholes at Puma Punku fall squarely within the operating range of computer-controlled industrial machinery. You'll say, maybe they had a harder stone bit and patience. Fine, then explain the feed rate. A feed rate of 1.5 millimeters per revolution requires two things: a drill bit harder than the material being drilled, and a constant axial force, meaning downward pressure that doesn't waver between revolutions. In diorite, that means a tool rated above Mohs 7. Diamond is 10. Corundum is 9. Nothing in the official Tiwanaku toolkit comes close. Copper is 3. Bronze is roughly 4. Obsidian, 7. but brittle under rotational stress and useless as a drill point. You'd need something the official timeline says didn't exist. And you'd need a mechanism to deliver constant pressure, not human hands, which tremor, fatigue, and vary stroke by stroke. Sit with that for a second. A feed rate measured in ancient stone that falls within the operating parameters of a modern, computer-controlled drill press. Not close, not in the ballpark, within range. The stone recorded every revolution, every calculation points the same way. And the most disturbing part is what comes next. The H-blocks didn't just fit together, they were clamped. Metal clamps held the stones in place, locking the modular system into a rigid assembly. And when researchers from the Universidad Mayor de San Andrés in La Paz analyzed the composition of these clamps, they found something that stops the conversation cold. The clamps are made from an alloy of arsenic, copper, and nickel, a ternary alloy that requires controlled smelting at specific temperatures and ratios. The metal wasn't cold-hammered into shape. It wasn't beaten from a nugget. Spectral analysis reveals it was poured molten, liquid metal, directly into T-shaped channels carved into the stone faces. Someone brought metal to its liquid state at 4,000 meters above sea level, where fire barely catches, where oxygen is so thin that maintaining furnace temperature requires forced air systems, engineered bellows at minimum, designed to compensate for the altitude deficit. The melting point of copper is 1,084 degrees Celsius. Adding arsenic lowers it slightly, but introduces toxic fumes that would incapacitate unprotected workers within minutes. Adding nickel raises the melting point again and requires even more precise temperature control. A modern metallurgist would need a laboratory-grade furnace, calibrated airflow, chemical feedstock, and protective equipment to produce this alloy reliably. Someone at Puma Punku did it in open air, at altitude, and got the composition right, consistently enough to clamp dozens of multi-ton blocks into a single structure. When the alloy's arsenic content, the nickel ratio, and the pouring technique are compared to the broader Tiwanaku archaeological record, nothing matches. It's an orphan technology, a technique that appears fully formed, performs at a level that implies generations of metallurgical refinement, and then vanishes from the record without successors. Like a toolbox that shows up at a construction site with no worker and no truck. What comes next destroys this version for good, the anomaly that makes the whole site stranger than any single block. Multiple independent surveys have documented a persistent magnetic irregularity across the Puma Punku platform. Compasses don't behave normally here. The needle drifts, it stutters, it refuses to hold north. When measured with modern instruments, localized magnetic field distortions have been recorded across the platform area. Distortions that don't align with the natural geomagnetic baseline of the Bolivian altiplano. The surrounding soil reads normal. The bedrock reads normal. The blocks read wrong. Two hypotheses exist. The first, the blocks contain ferromagnetic mineral inclusions, magnetite, in concentrations dramatically higher than the surrounding bedrock. This would suggest the stone was either deliberately selected for its magnetic properties or processed in a way that concentrated ferromagnetic particles within it. The geological record shows no natural diorite deposit in the region with this magnetic profile. The second hypothesis, more controversial, the blocks aren't carved stone at all. They're geopolymer, an artificial cement-like substance mixed with mineral aggregates, poured into precision molds and hardened in place. Geopolymer concrete can be engineered to contain specific mineral compositions, including highly magnetic ones. If the blocks were cast rather than carved, it would explain the impossible surface precision, the uniform dimensions, the internal drill holes, and the anomalous magnetic signature, all at once. Joseph Davidovits at the Geopolymer Institute in France has spent decades arguing this case for multiple ancient sites. At Puma Punku, the magnetic data gives his hypothesis unexpected support. Neither hypothesis fits the glossy version. If the stone was selected for magnetic properties, someone understood electromagnetic phenomena thousands of years before Faraday. If it was poured, someone had advanced material science that we rediscovered only in the 20th century. Either answer rewrites the accepted timeline. Compasses going haywire at an ancient industrial site. That's not a footnote, that's a flashing red light. And the site's own body tells the rest. Walk across Puma Punku today, and what you see isn't a ruin in any normal sense. It's a debris field. Blocks weighing over 100 tons are scattered across the plateau, some of them hundreds of meters from the main platform, oriented in random directions, half buried in mud and earth. They're not stacked in collapse patterns. They're not toppled in sequence like dominoes. They're scattered, chaotically, violently, as if hurled. The geological record shows no earthquake of sufficient magnitude to do this in the relevant time frame. No flood reaches 4,000 meters. No known landslide trajectory matches the distribution. The destruction pattern, analyzed by Arthur Poznansky in the early 20th century and revisited by multiple teams since, including Alexei Vranich of the University of Pennsylvania, is radial. It radiates outward from a central point on the platform. Blocks closest to the center are the most fragmented. Blocks farther out are larger, heavier, and thrown farther. Vranich's digital reconstruction of the original platform, painstakingly reassembling block positions from scatter patterns, reveals that the structure was once a single raised stone platform, roughly 6 meters high, covered in massive slabs. Something reduced it to a field of debris. And whatever that something was, it had enough energy to displace blocks weighing over 130 tons across distances of hundreds of meters. The evidence from different sources all points the same way. Something blew Puma Punku apart, from the inside. A collapsed building falls down. A bombed building flies outward. Puma Punku's blocks didn't fall. They flew. And nobody has explained what supplied the energy. But that's just the first layer. There's another one underneath. If Puma Punku was a temple, why serial production? Temples are unique. Every temple in every ancient culture is one of a kind. Unique carvings, unique proportions, unique ornamentation, reflecting the specific deity, dynasty, or moment. Puma Punku has none of that. No figurative carvings, no religious iconography, no statues, no altars. What it has is standardization, interchangeable parts, uniform dimensions, modular assembly logic, clamps, fastener points, tolerances. These aren't the hallmarks of sacred architecture. These are the hallmarks of industrial output. Based on the analysis, Puma Punku wasn't a city. It wasn't a ceremonial center. It was a factory, or the remains of one, a production facility that manufactured standardized stone components for assembly elsewhere. The H-blocks are not altars, they're parts. The grooves are not decoration, they're joints. The drill holes are not ritual marks, they're fastener points. The clamps are not symbolic, they're structural. Not a temple, but a machine. A machine that someone, or something, destroyed so thoroughly that we're left reading the wreckage like a crash investigation report. This isn't X, this is Y. Every comfortable label peels off when you apply engineering logic. Ritual complex becomes production floor. Decorative grooves become precision joints. Mysterious clamps become structural fasteners. The vocabulary of archaeology turns to vapor. The vocabulary of manufacturing takes its place. And here's where the warning lands. The glossy version, the polished, comfortable narrative that copper tools and determined labor explain everything at Puma Punku, isn't just incomplete, it's a trap. Accepting it means closing the door on every question the site screams at you. It means looking at CNC precision drill holes and saying, sand abrasive. It means seeing an industrial alloy poured at 4,000 meters and saying, lucky accident. It means walking past 100-ton blocks scattered in a radial blast pattern and never asking what scattered them. It means ignoring the compass in your hand as it spins. The warning is simple. The glossy version costs you the evidence trail. Once you accept it, you stop looking, and everything the stone is trying to tell you goes silent. The protection is simpler than you think. Look at ancient sites the way an engineer looks at a shop floor. Bring a straight edge, lay it across the surface, and check for deviation. Bring a Mohs pick set, scratch the stone, and rate its hardness against the tools the accepted version claims were used. Bring a compass and note where it misbehaves. Measure the tolerances with calipers, not assumptions. Calculate the energy required, furnace temperatures, airflow volumes, grinding rates. Compare the output to the tools supposedly available. When the numbers don't add up, don't adjust the numbers, adjust the story. Independent research has shown that this approach, physical measurement over narrative convenience, is the only method that survives contact with the actual stone. After examining the samples, the conclusion is always the same. The stone doesn't lie. The story might. And if you carry a compass and a straight edge to an ancient site, you've already done more due diligence than most glossy documentaries ever will. Let's just put these 7 facts on the table side by side. The hardness mismatch. Copper at 3, diorite at 7, and cuts cleaner than modern grinding achieves. The serial production. Interchangeable modular blocks with sub-millimeter tolerances, 18 centuries before the concept was invented. The CNC feed rates. Drill marks indistinguishable from computer-controlled boring. The orphan metallurgy. A ternary alloy poured molten at 4,000 meters with no precursor technology in the record. The magnetic anomaly, blocks that scramble compasses, in stone that shouldn't be magnetic. The radial destruction, a debris field consistent with internal detonation, not natural collapse. The total absence of religious function. No carvings, no altars, no iconography. Nothing but engineering. 7 facts, 1 site, 1 conclusion. Someone at 4,000 meters, in stone harder than steel, with precision that matches modern industrial machinery, built a standardized production facility that the official record cannot explain with the tools it allows. The evidence points to a civilization that the glossy version has simply edited out. Puma Punku is a factory. But factories don't exist in isolation. They need supply lines. They need roads. And there are roads, ancient, impossible, stretching across 5 continents. Next, 10 roads that science can't explain. Highways through jungles, deserts, and mountain ranges, built by civilizations that officially had no wheels. I've stood in a modern CNC workshop. The precision they achieve requires electricity, diamond bits, and climate-controlled halls. Someone matched it at 4,000 meters, in stone that eats copper, and left no manual. That unsettles me.